Welcome to this video. In this video, I'm going to talk about graphing linear functions. And we're just going to look at some linear functions, some linear equations, and we're going to graph them on the XY plane. So the objective is that you should be able to graph these linear functions, and then I'm going to show you how to graph a line segment, and it's really not too much more than graphing a line. But here we go. So let's graph a linear function. Now the first one we want to graph is in slope-intercept form. So if you recall slope-intercept form is y equals mx plus b, and that's nice because we have the slope and the y-intercept. So if we had the option of choosing which form we want it in slope-intercept form. It's easiest to graph. So let's look at an example here. And let's say I have y equals 2/3 x minus 5. So I'm going to go ahead and graph that. And in order to graph this, I'm going to start at my y-intercept here of -5. So that means I'm going to go down 1, 2, 3, 4, down 5, and plot that point on my y-axis. From there, I'm going to use my slope to tell me where to go, and I'm going to use that as my rise, and this is my run. So I'm going to go rise up 2, 1, 2, run over 1, 2, 3, and then plot my next point. Then I'm going to connect the lines, or connect the points, and there's my line. Okay, so that's it. That's all you have to do to graph a linear equation. Our linear function. Let's take another look at another example. Let's do the same thing. Y equals, except let's go negative. Let's go -4 x plus 3. So again, I'm going to start plus 3, 1, 2, 3, right there at +3 on the y-axis. This is my slope. It's -4 over 1. So -4 means I'm going to go down 4 units. 1, 2, 3, 4, and over 1 unit positive. And I'm going to connect these like that. And there's my line. What I do not want to do is go down 4 and then to the left 1, because I would end up with a positive slope. So I want to make sure I go down and over, or I can go up and negative that way, and that'll give me my line. Well, you say, that's nice and dandy, Mr. Myesis, if it's in slope-intercept form, but what if it's not in slope-intercept form? What if it's in standard form or something like standard form? Let's say we have something like 3x plus 2y equals 6. Well, I would say, student, what you want to do is you want to change that into slope-intercept form. So we do a little bit of algebra, so subtract 3x from both sides. Divide everything by 2. When I mean everything, I mean both terms here. So we get 3. Now that we have it in slope-intercept form, we're going to go 1, 2, 3, up 3, then down 3, 1, 2, 3, and over 2, 1, 2. Plot the points. Bada bing, bada boom. Draw your line. There you go. Okay, so sometimes you might end up with a fraction here. If you end up with a fraction, you're just going to have to estimate. Or you could plug in a value for x, solve it, and find what y is. That'll be 1 point. Plug in a value for x, a different value. Solve it, find that other value for y. That'll be another point. Connect the 2 points and you got your line. So that's another option if you don't have it in slope-intercept form. Finally, another option is to find the x and y intercepts by plugging in 0 for x, finding what y is, and plugging out 0 for y, and finding what x is, and then find those x and y intercepts, which in this case would be 3 and 2, and plot those. That'll also work. So you've got options when it's not in slope-intercept form. I think that the easiest thing to do is to put it in slope-intercept form and then graph it. All right? So that's how we graph linear functions. Now, let's say we only wanted to graph a line segment. Well, what we would need to do is we would need to have some restrictions on that. So what I mean by that is, let's say we have the line y equals 1/3 x plus 4, and this is going to be restricted between 0 and 3. So what that means is that I'm going to take a line, and normally I would graph this. Now the easiest, I'm going to just tell you the easiest way to do this. Normally I would graph this. You know, I'd go down, I'd go up 4 and plot my y-intercept, and then I'd go up 1. Let's do that. 1, 2, 3, 4. And then I would go up 1 and over 3. You know, plot my next point, then plot my line. But you know what? I don't want to do that. Let's do a simpler, and then let's do a simpler method here. Okay? So simpler method is, here's my x value of 0. I'm going to take that 0, I'm going to plug it in there for x. Okay, so I'm going to get y equals 1/3 times 0 plus 4, which is 4. Plot that point. Take my next end point, plug that in for x. I'm going to get y equals 1/3 times 3 plus 4, which is 1 plus 4, which is 5. Okay, so my point here is 3 comma 5. This one was 0 comma 4. Okay, so my endpoint is 3 comma 5 because the x was 3 and the y is 5. So I'm going to go 1, 2, 3 and up to 5 right there, and draw my line segment. Okay, now it so happened to turn out to be exactly what I had drawn in the other part, but if I had made this 6, then I would have to go out to 6 and up over to let's see, 6, 6 right here, okay, over here, and draw the entire line segment. So that is my line segment. It's restricted by a domain restriction here, an x. It can only go between 0 and 3. Okay, so there's my line segment. So here are a couple of practice problems for you to try. Okay, I'm going to put 2 here. I'll ask you to graph each. Okay, so graph the line. Graph y equals negative 4/3 x minus 2. And then go ahead and graph y equals, let's go with 2/3 x minus 4, and we'll keep that between -3 and +3. Okay, so this is a line segment. Okay, so what I recommend you doing now is pause the video, try the practice problems, because I'm going to draw the solutions right here. Okay, so pause it now. All right, here are the answers to this. So I'm going to go down 2, 1, 2. Then I'm going to go down 4 over 3. Draw my line that way. Okay. So there's my line. For this one, I'm going to plug in -3 in here. So I'm going to get 2 over -3. Oops, 2 over 3 times -3 minus 4, which is -2 minus 4, which is -6. So I'm going to have the point -3 comma -6, and I'm going to plug in +3 in here. So I'm going to have 2/3 times +3 minus 4, which is 2 minus 4, which is -2. So my next point is going to be 3 comma -2. So let me go ahead and plot those. Plot in this little space right here. Hopefully we can see what we're doing. 1, 2, 3. 1, 2, 3, 4, 5, 6. There's one point. The other point is 1, 2, 3. Down 2 right there. And I've got a line segment. All right. There you go, folks. Have a good day.